everyone, this is Himanshu, and in this lecture, we will study about the three-stage nuclear program of India. Now, India has a three-stage nuclear program. The three-stage nuclear program is actually developed with the aim of utilizing the vast thorium reserves in India, which are about 25% of the world, 25% of world. These are the thorium reserves of India. Now, because of this, as India has a limited availability of the uranium reserves, that is a 2%, so the three-stage nuclear program becomes, the backbone of the India's nuclear programs. So let's discuss about this. Now, let's talk about the first stage. So I'll make it here in a diagram format so that you can remember it. So this is the first stage. Now in the first stage, we will provide an input of the natural uranium this is a natural uranium. Now this first one is what we call as the pressurized heavy water reactor, that is a PHWR. Now the next stage, the second stage, we will get an output of this one as the plutonium. Apart from that, we will also provide thorium. So this will be like the thorium. So that's pretty much what we call as the the natural uranium also. So generally this would be the fueled by the mix of the plutonium and the natural uranium, with the sufficient stock thorium that is introduced to convert it into the uranium 233. Now we come to the final stage. So let us make it here. That is our third stage. Now we will provide the output of this one, that is the first uranium 233, along with thorium and most importantly the output that we will have from here, that is uranium 233 again. This will be transferred back to the third stage. Now let's understand what is the whole thing of this is. So when we talk about the first stage, the pressurized heavy water reactor are based on the natural uranium that contains 99% of the uranium 238 and uranium 235 by 0.7%. So here the compensation is basically the uranium 238, that is actually 99.9% or 93, so 99.3, that would be pretty much and the uranium 235, which is actually 0.7%. Now uranium 235 being a fissile, it set up a chain reaction, and uranium 238 being a non-fissile actually gets converted to the plutonium 239 as a byproduct, and which in turn is used in the fast breeder reactor in the second stage. So this reactor is basically the fast breeder. So fast breeder reactor. Now let's come to the second stage. Now the fast breeder reactors are primarily based upon the plutonium itself, as we have discussed earlier. Now further, the breeder reactor use a mix of the plutonium 239 that is produced in the first stage and the uranium 238 that is actually abundantly found on the earth to produce the plutonium reactor inside the reactor. Now, which is basically available in the nature, that is U-238 is not a fissile material, and obviously it cannot sustain a chain reaction. So since the amount of the plutonium produced inside the reactor is more that initially used, it is called the breeder reactor. And in order to increase the probability of the neutron hitting the U-238, these reactors do not use a moderator actually to slow down the neutron. And this is also one of the reasons they call the fast breeder reactor. So you can make a point here that they do not use a moderator, right? Okay. And so once the plutonium 239 is completely used here, the thorium is introduced in the reactor, which I written it here. So the natural uranium is also I've written it here, so you can if you won't get confused, so you can write it this also, that we have a thorium also, we have a natural uranium also. So once the the P239 is completely used, the thorium is introduced in the reactor to convert it into the uranium 233 that will be used in a third stage. Now let's come to the third stage. Now this is a thermal breeder reactor. So there is no space left to write. So let me write it here. This is basically the thermal breeder reactor. Okay, this one. So this is basically the third stage. Now the thorium is also actually not radioactive, and thus it is not fissile. Now in these reactors, the thorium 232 is converted into the uranium 233, which is actually a fissile material. Okay, and the one of the example of these reactor is basically the Kamini in India. So we'll discuss about that also later. So since India has abundant thorium reserves in the form of the monazite sand, that is a monazite sand found mostly in the Kerala, and also in I think in Chennai coast. And the third stage is actually the critical for the India's nuclear energy basket. So this is mainly about the three-stage nuclear program of the India and how we can make a best use of it. Similarly, the Kamini is the one basically which is the only one which is very important for the third stage Indian nuclear program. So the Kamini is basically a reactor which is operating in the world, which uses a uranium 233 fuel. So you can make a point of that. Apart from that, there are different nuclear powers in India, and we'll discuss that in the next chapter. So thank you guys, stay tuned.